good day everyone. Today we will going to discuss about lesson 3 of chapter 4, which is actually the continuation of your hypothesis testing. So now for lesson 3 we have the test statistics and rejection region. Okay, so what we mean by the word test statistics, before on lesson 1 I have introduced to you your hypothesis testing along with your um null and alternative hypothesis. On your lesson 2 of your chapter 4, I also introduced to you the types of error that you could commit in accepting or rejecting your null hypothesis. This time, how would we able to know the area which is actually need to be rejected, or what we call the rejected region, and the area that is also considered to be accepted, and that is done by the use of what we call test of statistics. Okay, now, so at the end of the lesson you must have A, illustrate rejection regions, B, determine critical values for hypothesis testing, and C, make a decision about the null hypothesis. So let us see if we will if we will be able to. Okay, there's somehow an error for that. Let's have that. Sorry. Let me check that one. Okay, so we cannot edit this one. Okay, let it be. Okay, so that's actually the word for that is rejection. Okay, now, so as you can see, we have this 3 aims for this one. Okay, next what we're going to do is that we need to learn. We will going to skip those activities. Okay, so we will going to continue with the explain part. So again, as what I have said in the previous lesson, we have the statistical test must be conducted on the collected data, and appropriate measures and decision making must be computed. Okay, so these measures are what we call test statistics and p-value. So in your chapter 3 we have already discussed about the p-value. Okay, now we will going to further discuss what is a p-value in this lesson 4. Okay, so as you have remember, okay, so we have here the word test statistics. So let us first define what is test statistics. So when we say test statistics, it is a numerical value computed from sample data, okay, that is sensitive to the differences between a null hypothesis and an alternative hypothesis. So why is it sensitive? It is because the numerical value or the test statistics is actually the kind of value that might change the value that could varies. Okay, so the first thing that we need to learn is the what we call significance probability, or what we call the p-value. So when we say p-value, that is a probability using test statistics value in the direction of the alternative hypothesis, assuming that the null hypothesis is true. Okay, and also it is known as the lowest level of significance that which the test statistic value is significant. So next, we need to determine the critical value, the critical region, which also determines by your critical value, or what we call the rejection region. Okay, so distribution of the entire set of possible value of test statistics divided into two regions. The critical regions or rejection regions and the non-rejection regions, or what we call the accepted region. So when we say critical or rejection region, remember we have the what we call the alpha and the beta, which we could commit, or what we call the probability of committing an error. Okay, so those are what we call, others are using that word as the margin of error. So consists of values that supports the alternative hypothesis. Okay, why? It is because your critical region indicates whether your values is included or can be accepted or included in the accepted region, or if it is in the rejection region. Because if it is in the rejection region, that only means that we need the alternative hypothesis. So the decision making is based on where your value is located, either in the rejection region or the accepted or non-rejection region. So it has an area given by the level of significance A, or what we call the alpha. Okay, so take note, we often use the Greek letter alpha. Okay, so the non-rejection region consists of values that supports the null hypothesis. Okay, so that means there is no changes in the computed value, or the computed value is still in the range of the accepted region. So the level of significance determines a critical value that divides a critical region in a non-rejection region. So remember your for your normal distribution, remember your z value that we have already discussed, the level of confidence that we have already discussed. So your 1 minus alpha is the level of confidence, but your alpha is actually given by 1 minus level of confidence, which is your alpha serves also as your, in this part, serves as your level of significance. Okay, this is your level of significance. Okay, and your alpha also determines your critical values. So later on we will going to know how that is possible. Okay, now, so let's continue. Okay, the level of significance determines the critical value. So if the alternative hypothesis is non-directional, meaning, remember, non-directional is determined by the not equal sign. Okay, and involves a quantifier, yes, that is not equal to, or not equal to. It is a two-tailed test. Okay, so when we say two-tailed test, if we will going to illustrate that one, we will going to illustrate that one using your, using your normal distribution. Okay, so this is your 0. Okay, so when we say two-tailed, that means the tail is located both side, which is the left and the right. Okay, so this also, when we say also two-tailed test, this also means that the rejection region is both located on the left and also there is one to the right. Okay, so this is called two-tailed because the rejection region is usually found or commonly found in the tail of your illustration. Okay, so it divides a critical region into two regions located in both tails of the distribution, and each critical region has an area of A over 2. Okay, take note of that. That is A over 2, which means that, okay, we will go into draw again. This means that if we will going to total the rejection region, for example, we have here the first rejection region. Another is we have, let's assume this is a normal distribution, we have another rejection region. So what will going to happen is it is an a over 2, and there is another a over 2 on the right side. Okay, so if we will going to total that, that is equal a plus a over 2 is equal to a. Okay, so this is your rejection region, this is your rejection region, and another is, this is your, okay, this is your, the remaining part is your accepted region, the green one. Okay, so take note always in the two-tailed test, your accepted region or your non-rejection region is located in between, okay, in the middle. Okay, so let's continue with our discussion. Also, for the critical region, this one, as you can see. So, this is a over 2, and then in the middle, that is the area which is 1 minus a. Okay, because a or your alpha determines your critical values or the critical values or your rejection region. Okay, so in a one-tailed test, the critical region is concentrated on only one tail of the distribution. Okay, so if the alternative hypothesis is directional and involves a quantifier greater than, it is a right or upper tailed tail. Okay, so look at the illustration. So what we have here. Okay, we have here in the illustration. So same goes, that will going to happen. Okay, but this time when we say it is greater than, the indicator is greater than, that is a right or upper tail test. Why upper? Because your critical region is located to the right part. Okay, right siya ha? Okay, right. There siya. There siya makita. We will going to locate it here. Okay, while if the alternative hypothesis is directional and it involves the quantifier or the symbol less than, that means it is a left-tailed test, or another term for that is lower-tailed test. Why lower? It is because it is located on the left part. Okay, so this time the scenario is different. Okay, it is located on the left part. That is why the term is left-tailed test or lower-tailed test. Why lower? It is because the critical regions are located on the negative part of your normal distribution, and also these values are the least values. Okay, next, so in making a decision or conclusion, we base it on where is the computed value located. For example, if we have left-tailed test, we are using the left-tailed test or lower-tailed test. And for example, the value is belong to the rejection region, then what will going to happen is we will going to reject the null hypothesis. Okay, but if the value belongs, for example, your critical value that we have here is -1. Okay, and the computed value that we have is -1.9. Okay, so take note that -1.9 is located to the left of -1, which is determined by our critical value. Okay, let's try. This is where is your -1. So if your computed value, for example, is -1.9, locate that on your accepted and your rejected region. So take note that 1.9, this is your accepted region. The orange is the accepted region. And since it is a left-tailed test, okay, and your -1.9 is located in this part. Okay, located to the right part here. To the left part, which is your rejection region. That only means we will going to base our decision or our conclusion to that location of your computed value. So that means we will going to reject the null hypothesis and we will going to accept the alternative hypothesis. Okay, so let's have an example for that. So these are the process. So first we need to state the null and alternative, of course, because that is where we're all going to base our decision later on. Okay, so why there should be an alternative if what we need is only to prove whether the null is either false or true. It is because directly after rejecting the null, we will going to use the alternative hypothesis. Okay, so as you can see, we have significance. We need to know the significance test, which is your p-value. So second is choose a level of significance, your alpha. Okay, so your alpha base is based on the given level of confidence. Take note, if you know the level of confidence, you know the alpha. But there are instances that the level of significance is also already indicated. Okay, so third is compute the appropriate test statistics. Okay, fourth, establish the critical region based on alpha. Okay, so based on the computed statistics, we have already the region. And fifth, it's going to be the decision making. So reject null hypothesis if test statistics falls to the critical region or your rejected region. If it does not fall to the rejection region, then you're going to you're not going to reject it, or you're going to accept the null hypothesis, meaning you need to accept that the original statement is true. Okay, so that's all for your lesson 3, and I hope you learned something. If you have any question, you can freely ask me regarding this one.